Hey there, Algebra 2 students. Let's go over some problems from 10.4 and 10.5, and this may very well be my last video for the school year. All right, so starting with 10.4, question number 3. Your dart is equally likely to hit any point inside the board shown. You throw a dart and pop a balloon. What is the probability that the balloon is red or blue? Okay, hopefully you can see this kind of clearly. Red balloons and blue balloons are disjoint, right? There's no overlap. There are no blue balloons that are also red balloons. So in order to find the probability here, we want to find the probability of the red balloon and add that to the probability of the blue balloon. So we have to count the total number of balloons. There are 20 balloons, right? What's the probability of popping a red balloon? 1, 2, 3, 4, 5, 6. So there are 6 red balloons, so it would be 6 out of 20. For the red, and for the probability of the blue, you count the blue balloons, 3 out of 20. So that would be 3/20ths, and so then you add the 6/20ths plus the 3/20ths, and you get 9/20ths is your answer there. That is the probability of A or B. Okay, so we will move on to the next one. You are performing an experiment to determine how well plants grow under different light sources. Of the 30 plants in the experiment, 12 receive visible light, 15 receive ultraviolet light, and 6 receive both visible and ultraviolet light. What is the probability that a plant in the experiment receives visible or ultraviolet light? So we need to do here is do probability of visible plus the probability of ultraviolet minus the probability of both visible and ultraviolet. And so the visible was 12 out of 30. Ultraviolet was 15 out of 30, minus the probability of both was 6, right? So 6 out of 30. So that's 27/30ths minus 6/30ths, or 21/30ths, which simplifies to 7/10ths. Okay? We're just using the formula, following the formula. Okay. This next one, it says a company is focus testing a new type of fruit drink. The focus group is 47% male. Of the responses, 40% of the males and 54% of the females said they would buy the fruit drink. What is the probability that a randomly selected person would buy the fruit drink? So you need to find that 53% of the population was female. And I made a chart for this one because it just helped me to visualize things more. To note, I put male, female, total on the top, yes, no, and total on the bottom. And we know that the total number of males was 47%, so that's a 0.47. The total number of females, well, the percentage was 53%, so 0.53. And the total would be 1 whole, right? This is a relative frequency chart. Okay. And we know that 40% of the males would buy the drink. So 40% of 0.47 is the 0.188. And so then the difference would be 0.282. Okay. 54% of females said they would buy the drink. So 54% of 53%. So 0.53 times 0.54 is 0.2862. And when you add those up, it's 0.4742 or 47.42%. Okay. And I filled out the rest of the chart just to clarify and wrap my mind around it all. but I hope that makes some more sense to you. Okay, so that's it for 10.4. We'll move on and do a couple questions from 10.5. So it says, find the number of ways you can arrange all of the letters for part A, and then B, 2 of the letters in the word family. Okay, so first thing we need to do is count the letters in the word family. Okay, there are 6, right? 6 letters in the word family. And if you're just looking for the number of ways that you can arrange all of the letters in the word, that's 6 factorial, or 720 different ways that you can arrange all of the letters in the word family. If we are going to choose 2, any 2 letters, it would be 6p2, right? So 6 factorial over 6 minus 2 factorial, which is 6 times 5 times 4 factorial over 4 factorial. The 4 factorials would cancel. You're left with 6 times 5, which is 30. 30. Yeah. Okay. Evaluate the expression 5p2. So I'm going to use the formula where we put the first number, we take the factorial of the first number and put that on top, so 5 factorial. And on the bottom we do 5 minus the second number, which is a 2 factorial. So 5 minus 2 is 3 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, right? And, well, I stopped at 3 factorial, and I put the 3 factorial down here as well. And I'm going to cross those out, right? Because they cancel. And we're left with 5 times 4, which is 20. Another way to evaluate that is to use your calculator. You can literally type into your calculator 5p2, execute 20. Okay, so that is 3. And number 5, you have 11 students that are competing in an art contest. How many different ways can the students finish first, second, and third? And so sometimes I like to just draw a little chart. Okay, each blank represents either first, second, or third place, right? And once the first place person has been chosen, right, so you have 11 options for the first place. You have 10 options for second place then, because the first place guy has already been chosen. And for third place, you only have 9 remaining because the first 2 have already been chosen, right? So you have 11 times 10 times 9. These are not fraction bars, They're just helping me to see first, second, third place, right? So we do 11 times 10 times 9, and that is 990. So 990 different ways. Okay, so that's 10.5 part A. Some answers. I may post some answers for 10.5 part B tomorrow, or we can talk about that at our Zoom meeting on Monday. I hope that you are all well. I will see you next time, whenever that may be.